Okay, so this video is all about continuity corrections. So first off, we need to define what a continuity correction is. So a continuity correction is when you are applying a continuous distribution to a discrete case. So our continuous distributions are normal, uniform, and triangular. So they can ask you to do a continuity correction for any one of those. It's more likely to be for the normal, however, okay? Theoretically, it could be any of them. So you've been lucky because you've grown up in an era where you've had graphics calculators that can work probabilities for a binomial situation. And it doesn't matter how big n is because you can just type it in a calculator and it will be able to work that out. Whereas this all came about because originally we couldn't necessarily do that. With large values of n, it became too hard to work out some of those things on the calculator. So therefore, we had to use an approximation to the normal distribution. And when n is large, so when the number of trials is large and the probability is around about a half, you get a fairly good normal distribution. But this is about what happens if I'm going to try and approximate using a normal, a uniform, or triangle distribution, and I'm asked to work out the probability of exactly a number. So let's say we could work out the probability of exactly getting 7 when we've got a mean of 5 and a standard deviation of 2. Well, you've got to think about the fact that in normal distribution is a continuous distribution. So therefore, the number which is, we said 7, but we've got a continuation around that would all get rounded to 7. So you've got to think, what is the smallest number that I could have that would round down to 7, and what was the largest number that I could have that would round up to 7? So the rounding up to 7 is easy. The smallest number that I could have that would round up to 7 is 6.5. The other side of that is slightly harder because the largest number that I could round down to 7 is 7.4 by our normal rule, but actually that's not true, isn't it? Because I could get 7.49 and then I could keep on going with those nines, and all of those nines are smaller than 7.5, which is when I would round up. Now, I'm not ever going to get you to type in 7.49999 recurring forever, because that's just insane, because that is so close to being 7.5, it makes no odds. So if you are applying a continuity correction and you are doing it to a discrete case, then you might find that you are going to choose either to go from 6.5 to 7.5, or say if it's got to be bigger than 7, you're going to go, well, this is being done in a discrete case, so therefore I'm going to be doing that from 7.5 and higher. Okay, so my first situation for a continuity correction is applying it to a discrete case. And then I can do that. Now, we said earlier on that we would never use NPD in our graphics calculators. If I was working out the value of exactly 7, NPD does this continuity correction for you straight away. However, it doesn't necessarily always work because it might be greater than, and you've got to be able to identify that it's a discrete case. The other time we might have to apply a continuity correction is if my numbers are rounded. So it's a continuous distribution, so if I said something like heights of girls at Westlake Girls High School are measured in centimeters to the nearest 5 centimeters. What's the probability that a girl is taller than, or taller or equal to, 175 centimeters? Well, again, let's think about our number line. So if they're rounded to the nearest 5 centimeters, I could have a 165, a 170, a 175, and a 180, because those are the only numbers that I could have when I've rounded to the nearest 5 centimeters. I want to be able to identify all the girls who are taller than or equal to 175, which means that anyone that was halfway between 170 and 175 would have been rounded up to 175. So what's the value in between? And that is 172.5. So then I would have to use that as my continuity correction in my calculation. Now, a couple of words of caution. First word of caution is don't go looking for a continuity correction where there isn't one. Okay? You don't want to always be applying this. It's got to be either a rounding one or you are applying a continuous distribution to something that is discrete. I.e., I'm applying a normal distribution to shoe sizes which are discrete. So that is my first warning. Second warning is I always draw out the number line as I have done on the screen and shown how I get there, because that means I'm less likely to make mistakes. Some people can do this in their head. I often would not be able to do that. So I find that the easiest way. Okay? And that's continuity corrections. So that's our last bit. Have a good day.